Hi, this video is going to be on how to write a rational function with given features. I thought it would be an interesting thing to show you because this will help you understand some of these aspects related to vertical asymptotes, horizontal asymptotes, holes, y-intercepts, etc. etc. Let's take a look at this problem. What we want. We want a vertical asymptote at x equals 2, a horizontal asymptote y equals 0, no holes, and the y-intercept of 0, 3. Let's think how we can put it all together. So if you want a vertical asymptote at x equals 2, that means the denominator has to be x minus 2 because that would make it an excluded value, right? If we don't want any holes, that means we do not have the same, we're not going to have another factor on top that's going to be, and another factor on the bottom that are going to be canceling each other. But we're not even going to bother with that right now. We want the horizontal asymptote to be y equals 0, which means since the degree on the bottom is 1, the degree on top has to be 0, so we're going to have to put some kind of a number here. So what number would that be? Well, if you want the y-intercept to be 0, 3, then whatever number you put here for x, when you put 0 for x, you're supposed to come out with 3. So let's see, if I'm putting 3 on the bottom, 0 on the bottom, then I am going to get -2. So something times -2 has to give me 3, because when I plug in 0 into the denominator and get -2, I want my outcome to be 3. So what number goes there? -6. So our function is going, or one possible function that's going to meet these criteria is going to be this one. I want to write another function with a vertical asymptote at -3, horizontal asymptote y equals 2, no holes, and an x-intercept of 2, 0. So what does that mean? That means the denominator must have x plus 3 as a quantity, as a factor, or possibly just the only thing. We want the horizontal to be y equals 2, so that means we have to have the same degree on top, and that degree would have to be, so it's going to be linear, right? So, but the coefficient has to be 2, because when we divide the leading coefficient, we want to make sure it's going to be 2 over 1. So it's 1 here, so it's going to be 2x, and then we need to complete that. We want an x-intercept at 2, 0, which means the numerator, when x is 2, we want it to equal 0. So that would be -4. Let's check. Vertical asymptote at -3, a horizontal asymptote at y equals 2, and if you substitute 2 into the equation, you're going to get 0, which makes it an x-intercept. So our function is going to be 2x minus 4 over x plus 3. Now we're getting a little bit more complicated with this. We want a rational function that has a vertical asymptote at x equals 4, horizontal asymptote y equals 3, a hole at x equals 1, and an x-intercept at -2, 0. Let's see how we can put this all together. So we need to have the denominator that's going to have x minus 4, because that would give you a vertical asymptote at x equals 4. We need a hole at x equals 1, which means we need to have x minus 1 and x minus 1 as a common factor in both the denominator and the numerator, because then this is going to give you 0 divided by 0 when x is 1. What else do we want? We want a horizontal asymptote y equals 3. That means we already have degree 2 on the bottom, and we have degree 1 on top, which means we have to have another linear factor here. And that linear factor, we want it to be so that when x is -2, the whole value of the whole thing is going to be 0. So that would mean we need x plus 2 as a factor. Let me run through this again before I finalize it. There's one more thing we have to do. So we want a vertical asymptote x equals 4. When x is 4, the denominator is 0, the numerator is not. We want a hole at x equals 1, so we want 0 divided by 0. That is this part. We want an x-intercept at negative 2, 0, so we need x plus 2 as a factor in the numerator. We also want our horizontal asymptote y equals 3. Right now, the way this is, the horizontal asymptote here is going to be 1 over 1, which is 1. So what we do is we add 3 here, and that's what we get. So all we need to do now is put it in standard form. So let's distribute this. The numerator is going to be 3x squared plus 3x minus 6 all over x squared minus 5x plus 4, and that is going to give us that function. And then one last example. Alright, no vertical asymptotes, a horizontal asymptote y equals negative 1, no holes. So these two things here tell you that whatever you're going to have on the bottom is not going to give you any real zeros. So it's going to have to be possibly binomial in the form like x squared plus number. We don't know what number that might be yet, but let's just write this. We want a horizontal asymptote to be at negative 1, right? So there's got to be a coefficient here of negative 1. What else do we want? We want two x-intercepts. One of them is going to be at negative 1, 0. The other one is at 3, 0. So how do we accomplish that? We're going to have x plus 1 times x minus 3 as our factors. And we want the y-intercept to be 0, 3. We're going to get to that because we don't know what that's going to be just yet. So let's distribute the numerator that we got so far. It's going to be negative x squared plus 2x plus 3. And on the bottom we have x squared plus some number. Right? Again, I want to remind you that x squared plus number will not give you any real zeros, and then you do not have any vertical asymptotes or holes. Not even possible. And we want our y-intercept to be 0, 3, so when x is 0, y has to be 3. So let's see, 0 here, we're getting 3, 0 here, so that number would have to be 1. And our function is going to be f of x equals negative x squared plus 2x plus 3 divided by x squared plus 1, and we are done.